All right, I assume you all can see this unless I hear otherwise, but so let's officially welcome everyone to the presentation today where we will, per the title here, create an Edge ML solution using tooling from ST Microelectronics and the Note Card and Note Hub from Blues. And I'm going to show you how to add intelligence to previously disconnected products like this smart toaster here, which is kind of a joke, but also kind of not. I will be showing how to create a very simple machine learning model using NanoEdge AI Studio, and arguably just as importantly, how to add wireless connectivity to relay alerts based on the inferences generated by those models. Now, in some ways, to me, this comes at a pretty critical time for both these industries, the Edge AI and IoT. If you're familiar with Gartner's hype cycle, they love to place emerging technologies on this fancy scale here. And the IoT in general, granted their latest hype cycle is a couple of years old, but the latest report puts the IoT down here in the trough of disillusionment. And Edge AI is nervously heading down the scary part of their roller coaster ride as well. So I might argue that the two of them really are starting to need each other to be successful. And I think you'll see a very small slice of that play out today. Quick introduction. My name is Rob Lauer. I'm Senior Director of Developer Relations here at Blues. Now, I'm not an expert in embedded development. I'm not an expert in machine learning. I know just enough to be dangerous in both. But this is also really the beauty of what I'm going to show off today. You don't have to be a data scientist to be able to implement some pretty powerful AI solutions with the modern tooling and services that are out there today. And I also want to give a shout out to RIoT. This is the Raleigh Internet of Things group. This is a really big organization for the IoT, like community hub, if you will. In fact, we have Jen Morgan on the call here from RIoT. Jen, do you want to provide a little more context for people who aren't familiar?
Yeah, absolutely. Thank you so much, Rob. Hi, everyone. My name is Jen Morgan. I work with RIoT. We just celebrated our 10th anniversary yesterday with a big celebration in Raleigh for those of you who are tuning in from that area. I know some of you came out last night. So yes, regional Internet of Things nowadays, as we've expanded well beyond Raleigh and into areas like Wilson, North Carolina and Stafford, Virginia, where I'm actually based, and we have meetup chapters all over the country and members all over the world, partners all over the world. Our organization, we are a global network of individuals, businesses, startups, government partners, companies, all united by a common goal to advance the frontiers of IoT, AI, data, technology, really to grow that thriving economy. So we try to connect people through introductions and education and create those opportunities for one-on-one collaborations and networking and convening, as well as highlighting great partners and sponsors like Blues in our network, creating opportunities to get them out there and meeting people. And we also run a startup accelerator program for new companies who are emerging, who want to get connected and learn more on how to grow and scale in this changing economy. So I'm happy to connect further with anyone who wants to learn more about RIoT, how to get involved, how to partner with us. But really, shout out to Rob and Blues. Thank you so much for allowing us to join today, and looking forward to the presentation.
Great. Did I really get the name wrong? It's now Regional Internet of Things.
Well, we went from Raleigh to regional to just RIoT because
Gotcha.
it all gets real confusing, but we'll go with anything. So
Awesome. All right. Yeah, as Jen mentioned, head to riot.org after the presentation to learn more. It really is a great organization. Now, as you have questions during the webinar, of course, feel free to ask those using either the chat or the Q&A panels that are provided through Zoom. My colleague TJ, who I did not properly introduce, he's on the line here to help answer questions while I'm doing a lot of the talking today. Of course, the first question we always get is this being recorded? Of course, it's being recorded, and it will be available on the Blues YouTube channel at this URL. Of course, feel free to subscribe as well when you get there. Now, I want to start today at step 0 well, at least for me, it was step 0 to help answer this question: what even is machine learning? And in full transparency, if anything, when I got started, I learned right away that 60% of the time it works every time, right? Machine learning is highly imperfect. As a very practical example, when I first got started in this realm of machine learning, I didn't start with any guides or tutorials. I just started like downloading some publicly available models, ML models, and some code that was available, and just start using it. And literally one of, if not the first attempt at using ML with this concept called image classification was taking a little squishy stress ball here and running it through an available image classification model. And the results were, as you can see, sketchy at best. So I had to take a couple steps back and start doing a little bit more research. And I really started my ML journey reading quotes like this. So ML is the study of computer algorithms that improve automatically through experience. And by the use of data, it's seen as a part of AI. All right, I kind of get it. It's a little bit complicated. So I reframed that quote a little bit and realized it was more like this simplified version, for me at least, which is ML lets computers learn from data versus being explicitly told what to do. Now, this is pretty wild for me because as an engineer at heart, what I try and do all day, every day is basically tell a computer to do something. ML is a different paradigm where it's like, hey, computer, here's a vague idea of a problem I want you to solve in the future. Let me know how you interpret future questions I send your way based on data. Like very, very different paradigm, right? And to use machine learning in practice, you need you need a model, right? And at its core, an ML model is a file. Sometimes that is just a massive set of integer arrays. The model file has been trained, if you will, to recognize patterns in data. Could be images, could be text, could be audio. Today it'll be XYZ positions streamed from an accelerometer. But these models are only as smart as we train them to be. For instance, given this image, if you trained a model on publicly available images of cats, would this cat be recognized? I mean, a 3-year-old could recognize it as a cat, but it has no fur, it's wearing a robe, kind of weird. My point here is that finding success in machine learning is really about providing the right instructions or the right blueprint to enable your model to learn appropriately. So for today, we can think of ML as providing some guideposts, if you will, for a computer to learn from and make its own inferences. Now, a subset of machine learning is this field of Edge AI or Edge ML or TinyML. You've heard it named all sorts of different things. This is really the idea of utilizing very small and highly optimized machine learning models on very low powered devices, often on tiny little microcontrollers. Now, since you're here, you're probably already well aware of the benefits, and I'm not going to read through all of these. But when you think about generating ML inferences on an edge device, for me, the number one thing that stands out is privacy, right? Private data stays on device. It doesn't go to the cloud for processing. If you're taking pictures of people's faces, for instance, and attaching metadata to that, you don't want to risk that data being compromised. So rather, you want to process it on the device, generate anonymized data, dump the private stuff from memory. But there's other advantages, of course, as they're laid out here. And again, you probably have your own ideas of where and how you can implement your own ML solution. If you need some inspiration, here you go. But I can honestly say that among Blue's customers I talk to, almost everyone has some kind of use case for ML, which is pretty cool because it doesn't matter what industry or vertical you're in, there's always something that some part of ML that you can take advantage of. Now, there's also numerous ML platforms you can use today. Personally, I am a massive fan of Edge Impulse, which lets you build and train ML models in the cloud and then deploy them to virtually any modern host device available. But there's certainly other options like TensorFlow Lite from Google, which Edge Impulse is at least partially built upon, I believe. PyTorch is another very popular one. ST also has a more advanced AI tool called STM32 Cube AI, which from my understanding is geared a little more towards data scientists. But today we're going to focus our time on a different tool from ST, and that is NanoEdge AI Studio. And as already mentioned, we're going to pair it with some hardware and services from Blues to build out really a fully functional end-to-end AI-powered device to cloud product in about 15-20 minutes. So let's first start with a little background on NanoEdge AI Studio. So you can use this tool to build and deploy to any STM32 Cortex M0 through M7 processor. So to be clear, it is STM32 only, which should not be a huge surprise considering who this is coming from. What was a bit of a disappointment for me is that the tool is only available on Windows and Ubuntu. There's no Mac version. Come on, ST, you can do better than that. However, it is a tool built for embedded developers, not necessarily data scientists, so it's pretty easy to use. And whether or not this is a pro or con, I'm not sure yet, but there are no cloud dependencies at all. That's because training of the model actually happens on device. It's a very interesting feature we're going to look at in more depth in the demo. And at one point, I heard this quote from someone at ST about this product, and it kind of resonated with me. NanoEdge is effectively like a search engine for ML libraries. That's because it ships with a ton of pre-built libraries that the tool will automatically pick for you. And it'll make more sense as we get into the demo here in a little. Now, I stole this image from ST. I hope they're cool with that, but it helps to describe at a very high level the process that we're going to go through. On the left, you can see that we will use NanoEdge to create a custom anomaly detection library on my PC. But then we're going to use the microcontroller itself to train this custom model and then start generating inferences on a recurring basis. And to be clear, NanoEdge supports 4 specific types of ML models. So you can discern normal versus abnormal behaviors directly on the STM32. You can detect anomalies in real time by using an anomaly detection model. That's what we're going to be doing today. You can also build one-class classification models. Those can be used to identify outliers in data patterns. And this is especially useful when no examples of anomalies can actually be detected. There's also N-class classification models. Those help you classify or group multiple inputs in real time. There's also extrapolation models. Those let you predict values based on data patterns that may or may not even have been seen before. That's all a lot to ingest, I realize. So today we're going to focus on what I consider the simplest of the 4, and that is anomaly detection. And now how you might actually get started with anomaly detection, well, there's a variety of common environmental sensors you could use, from using an accelerometer to detect vibration patterns. That's a common one. You can use pressure sensors. You can measure gas levels, volatile organic compounds. You can measure and track voltage levels, look at changes in magnetic fields, temperature and humidity, of course, light sensors, proximity sensors, comparing audio levels. You can even combine these so you're not limited to just one sensor. And today I'm going to be using an accelerometer that streams XYZ position values to the host. And for the host, I'm going to be using the STM32L4 based Swan that we offer here at Blues. Now the host is going to use that ML model to generate anomaly inferences based on the data it receives. So it's a very simple but pretty powerful concept. But when writing our code, writing our firmware, we still need to add some logic, right? We still need to interpret those inference values and ideally send an alert as quickly as possible when anomalous behaviors are identified. Now, of course, this is where Blues comes into play. If you're not familiar with Blues, this is the core hardware product we provide. It's called the Note Card. This one in particular is a dual cellular and Wi-Fi IoT device. The cellular side comes with prepaid with 500 megabytes of data, 10 years of global service. That's all baked into the cost of the device. There's no monthly SIM fees, no monthly data fees. But the Note Card, the hardware is only half the story for us. The other half is our cloud service that we call Note Hub. And the two work together to form a device to cloud data pump. So what this generally means is developers will buy a starter kit from us. Maybe they'll hook up one or more sensors to it. They'll start reading data with the host microcontroller and then start delivering that data securely over cellular, over Wi-Fi to Note Hub. And Note Hub will then route that data to their cloud or generate alerts like we're going to be doing today. So to be clear, Note Hub is a cloud service, but we are not trying to create a platform that locks you in. We want Note Hub to be relatively transparent. We exist to help you connect to your platform. Maybe that's AWS or Azure or DataCake or UbiDots. But there are a lot of Note Card options, to be clear, not just cellular, and they're all swappable both in terms of their physical connector and their APIs. We do have a line of cellular-only Note Cards. We have a low-cost Wi-Fi-only Note Card. There's a relatively new, again, low-cost LoRa-only Note Card. And the aforementioned dual cellular and Wi-Fi Note Cards that let you use either cell or Wi-Fi, or even this Wi-Fi to cellular fallback capability. Finally, we just recently announced a satellite add-on for Note Card called StarNote. This allows for fallback satellite communications in supported regions. So pretty exciting product line. Now to look at the Note Card just in a tiny bit more detail, it is a low power system on module. Most of them measure a tiny 30 by 35 millimeters or 30 by 42 millimeters for the Cell plus Wi-Fi Note Card. It does again have that M.2 edge connector for embedding in your project, but we do offer a line of carrier boards that we call note carriers that let you hook up your note card to any host you want to use. As mentioned, cellular-based note cards come prepaid, 500 megs of data, 10 years of service. The note card also has an onboard embedded SIM, but provides dual SIM support and the ability to switch between them. And the API is all JSON-based. So, well, we make that even easier to use with a variety of SDKs. So we have supported SDKs from Python, Go, Arduino, C, and Zephyr. So again, with everything being JSON in and JSON out with the note card API, for example, if you want to get your note card's location, your GPS location, if you're using a cellular note card, for instance, you would simply call card.location, and it's going to return the requested location in this kind of a format. So the REST API is very straightforward, set up very similar to this. And frankly, our SDKs make this even simpler. So if you're not used to working directly with JSON, there's still a path for you. And finally, in terms of completing that device to cloud story, we get to NodeHub. I would say the most important thing to know about NodeHub is it acts as a secure proxy that lets the node card communicate with the cloud. NodeHub takes care of all the security considerations and cloud connectivity. NodeHub lets you deliver or route note card data to any cloud application, any cloud service. For example, today we're going to use NodeHub to not only monitor our device, but also send email alerts based on thresholds that are set on ingested data, so data it receives from a note card. And in terms of security, when I talk about that, when you're talking about the cellular note card, data is transferred off the public internet between note card and NodeHub. It uses private VPN tunnels, can optionally be encrypted if you want to as well. So there's no certificate management, there's no key rotation required when you use the pair of note card and NodeHub. And now to help kind of visualize everything I just threw at you from the Blues ecosystem, let me walk you through a quick diagram here. Well, the cool thing about Blues to me is that we are microcontroller, single board computer agnostic. You can use STM32, ESP32, Nordic, Raspberry Pi, it doesn't matter. You can bring your sensors, whatever they be, use your programming language, right? We're not dictating any of that. You're going to then compose packets of JSON data that we call notes. These notes or these events are then queued, they're stored on the note card, and then at a cadence you specify, they are synced with NodeHub. Again, we don't want your data to live on NodeHub. That doesn't make sense for you, it doesn't make sense for us. We want you to route that data out to your cloud application, your cloud service of choice. Could be something custom that you're running, or something hosted in AWS, Azure, or an IoT platform like UbiDots or Losant or DataCake. All right, so with that intro to NanoEdge AI Studio and the note card and NodeHub, let's actually build something. So our technical demo today is going to involve supplying the tool, NanoEdge, with the type or types of sensors we're going to build, we're going to use to build the ML model. We're going to then start piping in over serial data from the accelerometer. Once NanoEdge knows the type of sensor and has examples of the data it will be receiving, it will then automatically pick a custom library for us based on those inputs. We are going to then upload this library to our STM32 device, the Swan, perform some super quick training on the device, and then automatically switch over to generating inferences and sending data to NodeHub to create alerts when necessary, all in about 20 minutes or so, trust me. Now, the reason you can trust me is that this demo was pre-recorded. Why? Well, because I'm deathly afraid of trying to run a complicated demo like this live, but also because I'm on a Mac right now and my Windows PC is over to my right. So if you give me a second, I'm going to switch over to the video and I will still be here, of course, to answer questions as they come up during the video. And I'm sure I made some mistakes during the video that I can could talk about in the chat. And let's see. All right, here we go. All right, welcome everybody to my Windows PC here. And I'm assuming that the other Rob gave a fine high-level introduction to NanoEdge AI Studio. And I am here to provide more of an in-depth demonstration. And I say in-depth, but we're going to do a relatively simple anomaly detection project here. So what you're seeing right now is NanoEdge AI Studio. And what I want to start off with is creating a new project. And of course, when you start up NanoEdge AI Studio, you are provided with a bunch of resources here on the right. So there's some links to some articles, some support articles. There's also actually quite a long list of project inspiration documents that you can read through. I find those to be quite useful when trying to understand some other practical use cases for this tool. But again, we're going to keep it pretty simple here and start with one of these projects. Again, we're going to stick with anomaly detection. So let's kick it off here and start a new project. So the first thing we're going to do is hit the Create New Project button. And again, as described in the slides, what we need to do is first supply the type of sensor that we're going to be using for this project. And we're going to be using a triple axis, so a 3-axis accelerometer, which is now actually probably a good time for me to show off the hardware that I'm using before I get too far into this project. So what we've got is just a portable fan setup here that's going to simulate an industrial machine. So any kind of pump or system that has movement in it, which is going to generate vibrations, which we want to detect differences in vibrations. A fan is a great option because obviously I can turn it on or off or change the speeds as well. So I've got my 3-axis accelerometer. It's an Adafruit LIS3DH, a very common, very stable accelerometer to use. It's connected over a quick cable to my note carrier F. This is a great board for prototyping using the note card, and I've got a Cell plus Wi-Fi note card. This is the wideband WNBAW, so it's got cellular and Wi-Fi on the board. I'm using a STM32 based Swan. Again, anything that you're using with NanoEdge AI Studio has to be an STM32 based board. And I've got a LiPo battery hooked up to it, and I'm using an ST-Link to make it easier to program my firmware on the Swan. And I've got another micro USB cable used primarily just to read data off the serial port, so just a convenience for me. So everything's set up really well here. I'm going to go ahead and next select my target architecture. Now, in my case, so I'm using the Swan, which is an STM32L4 based board, and Swan is not listed here in their explicitly supported development boards. But I found if I just do a simple search for STM32L4, I'm provided with a bunch of L4 series boards. Honestly, I found I can just choose any of these and it works just fine. This one, I believe, the Nucleo L4, this has worked just fine for me. So I'm just going to confirm this, and let's save and go to the next option. Now we want to start adding some signals, and signals are just inputs here. So the second step here is to supply what it says are regular signals. So these are what model the ML model needs to identify like a nominal or a normal signal from the accelerometer. And to do that, we need to start streaming out some normal accelerometer data from our board. So I'm going to head over to my first Arduino sketch, which I'm using Platform IO in VS Code here. And we can see in my main.cpp, what I'm doing here is it's very straightforward, right? I'm utilizing, again, the LIS3DH accelerometer, and we're initializing the board. I'm outputting some information just to show the range of the board and the data rate as well. This is totally unnecessary. We'll see what the values are. I believe it's like the range I have set is 2G, and the data rate I believe is 400 Hertz, which works fine just for this project. The most important stuff is what happens in the loop. We're just going to be streaming out data. We're going to be adding this to in chunks of 16 readings at a time, which is the buffer that NanoEdge AI Studio needs to process the data. So let's just get this loaded up on the board. In fact, with everything set up here, I believe I can just go ahead and compile and upload. And that was pretty quick. So let's first take a look at the serial monitor. I believe we're on COM4 and see what kind of data is coming out. So this looks pretty good to me. This is not streaming super quickly, so we could definitely do it faster. You'll notice I have a small delay here at the bottom. But this is what I've found to be a good data rate for NanoEdge AI Studio to process, to input the appropriate accelerometer data. So you'll see we're getting XYZ values, the 3 axes from the accelerometer. In fact, if I stop monitoring, we can see this in a little more detail. I believe this is going to be our typical reading here. So with the fan off, we're saying this is our nominal reading. Obviously, we could do this any other way. We could have the fan running at a full speed and that be our nominal. Right now, I'm just saying off is nominal. Now with this running now on the firmware, so it's still outputting data over the serial port, we're just not viewing it with the serial monitor. Let's head back over to NanoEdge AI Studio and start adding a signal here. We can actually add signals from files or a data logger. I'm just going to keep this simple again, and let's do this from serial. Make sure the right COM port is chosen, which it is, and the baud rate is correct as well. So in fact, we can just hit start here, and we can start importing that data. Now, you can see since the accelerometer is very sensitive, so you can see some variation here in the 3 axes, but the fact that the fan is not on, it's pretty obvious here, right? It's pretty stable over time. Now I'm just going to let this run to gather a fair amount of data. The more data we supply, the better the library is going to be in the end. So I might recommend in this case, I mean, for a proof of concept like this, I might just let this run for maybe a minute or so. In a real world scenario, you're going to want to train the best model you possibly can. So you probably want to let this run for minutes, for hours. It really depends on your specific use case, but it's all pretty reasonable when it's all said and done. And since I can't think of anything else to talk about right now, I'm going to go ahead and stop this. And this will be we'll use this as our base data set for this model. And we can get a preview of some of the data that came in from our accelerometer. So, take a quick glance through here, and you can kind of see some pretty stable numbers that are coming through. I guess there is some variation, unless I'm not quite looking at it right. The z-axis looks kind of different, but should be okay. Let's just see how this goes. So we can input this data. Now again, if I'm doing a production model, I'm probably going to want to enter multiple sets of signals here, but we're going to keep this pretty simple. We can actually specify some filters. So if we want to filter out some high and low range frequency data, if we have some outliers maybe in our data set that we don't want, NanoEdge AI Studio does allow you to do that. We're going to keep this simple. We can see a visualization of the mean and standard deviation and minimum and maximum for all 3 axes here on the right. Again, eyeballing this data looks pretty stable to me. So let's navigate now to the abnormal signals. So this is just going to provide NanoEdge AI Studio some hints as to what we think an abnormal data set is going to look like. And what's interesting is that this isn't strictly required, but it's useful to help NanoEdge AI Studio pick the right model or the right library to use for us. So without disconnecting anything here, I'm going to turn the fan on. I'm going to turn it on the highest setting so we get the most vibration coming through. What's interesting too about this, I have this mounted via some sticky foam here on the back, which dampens the signals a little bit, but actually the accelerometer is sensitive enough to detect the slightest in vibrations. So let's go ahead and start adding signals, same way we did it before over serial. All the selections look good there. You can immediately see in the visualization here that the data coming through is quite different, right? There's a lot more movement in the XYZ and XYZ axes here. So again, we can kind of let this run. We'll accumulate, I don't know, 200-300 lines of data until we hit stop again. That's probably pretty good right there. So let's just hit continue and import that data. And again, you can see the high-level visualization here of some of the data that came through. Now in the benchmark step, we can actually run a new benchmark to get an idea of the flash and RAM utilization for this library. I've got a really beefy Windows PC here running a pretty high-end AMD processor, so I've got a lot of cores to use. This benchmarking can take quite a bit of time if you have a lower end a processor to use. This one's going to be pretty quick. I'll show you what this actually is doing behind the scenes when this gets started. So as soon as we get our visualization up here, it's pretty interesting. It's going to start analyzing this data and help us pick the best possible library for us. Again, I like how they position NanoEdge AI Studio as a search engine for ML libraries, because it's going to do a lot of work here to pick the very best library for us to use for this project. Now you'll see the score here at the top says 48. We want to wait until that score gets well above 90%. That means that it'll be, it's the time when the data that we supply, whether it's a normal or abnormal signal, is analyzed, or the inferences are most correct. And we can see already that the blues are, these are the nominal, the normal signals. We want all those basically to get above this 90% line, and already, you know, pretty quick. So again, pretty fast processor here. The longer we run this, I think the closer it'll actually get to 100%. For the purposes of this demonstration, probably not necessary to get too much further. And we can see the amount of RAM that estimates this is going to use is 1.4 kilobytes, 3 kilobytes, a little bit higher, 3.6 kilobytes in flash. Boy, that looks pretty darn good to me. And yeah, 0.4 kilobytes of RAM now. Pretty impressive, frankly. Let's see, the validation step. That's the next one up here. This is going to let us go ahead and validate the selected model based on the benchmarking data. So this is an optional step. You don't have to do this. It's I don't know. It's another way to kind of validate that NanoEdge AI Studio has picked the best model for you. I'm going to skip over it in the interest of time. I'm also going to skip over this step. Not because it's not interesting, but frankly, I was never able to get it to work. So there's actually an ST emulator, STM32 emulator you can utilize on either Linux or Windows. I couldn't get it to run properly, so I apologize to ST. This is not a great demo because I'm not able to get the emulator to work. I did see it work in a demo, so I know it does work, but I guess maybe it's my fault, not sure, but it doesn't matter because we already have a good library chosen, so we can go ahead and skip to the deployment phase. Now, arguably my favorite part of this whole tool is the fact that they provide you a hello world, as they call it, sketch here on the right. So it's a bunch of C code that you can use as the basis for your firmware on your device. What I'm going to do, I've already copied this in, and I'll walk through some of the code briefly in a second, but I'm going to go ahead and compile this library, and we're going to get a precompiled .a library that we can include in our project. It does ask you to go through some quick survey questions. Let's say it's internal small company to actually get the compiled library. And so let's save that to our desktop and save it in my downloads folder. All right, we're actually done with NanoEdge AI Studio, so we can go ahead and minimize this and minimize this guy as well. And we're instead going to skip over to our new project, which is the sketch I've loaded that is going to do everything else from here on. So what I will ask you to do right now is kind of blur your eyes or skip over some of the blues or the note card and the note hub specific sections of the code. We're going to come back to this when it comes to generating the alerts. Instead, we're going to look at what's actually going on here. So my first step is going to be to include that library in my lib folder here in my project. So I'm going to go to my downloads. Let's quickly extract this compiled library, and I can just drag this into my lib directory. And I need to tell Platform.io to I need to give it a hint as to where this directory is in my project. So you just use that with the you specify that in the build flags here. So that should be right. We're actually specifying the name of the NanoEdge AI library as well. So there's two different flags you need to add to your project. And I'll save that. Now in the code itself, I've got a fill buffer method, which is just going to take that inputted serial data from my accelerometer to fill a buffer that the NanoEdge library is going to use to generate these inferences. Again, we're going to skip over the note card stuff for now. We initialize our accelerometer, and we get to what I find to be a quite interesting feature, if you will, of NanoEdge AI Studio, and that's because the learning actually happens on the device. So in our setup method, the first thing this device does when it starts is it's going to learn based on whatever the inputs are after the restart. This means that you can actually dynamically change what normal and abnormal means after it's been deployed to the device. Case in point, let's start this up with our fan turned off, so in the nominal state that we started with the first time. And as soon as we get this running, we'll see that when this data is processed, we're going to either see this text of normal or anomaly returned from the model, along with an integer, a number that is the inference that's generated. It's a numerical value from 0 to 100 based on how close to normal the reading is. And so that's about it. So every I don't know what it is, every 200 milliseconds, we're gonna spit out the inference generated by the model running on the device. So let's get this running on my Swan here. I'll take a moment to compile. Okay, the compile is finished and it's been deployed to my device. So let's just take a peek here at our serial monitor so we can see what's happening. Again, switch over to COM4, start monitoring, and we can see that it's took 30 iterations to learn, and it's outputting normal data, right? What it's receiving from the fan is minimal vibrations, if any at all, which it defines as normal. Now, if we go ahead and turn this fan on, we should see it immediately switch over to anomalous data, which we do. That's awesome, right? Now, great, we're done, right? And this is awesome. So, again, what I think is super cool about this NanoEdge AI Studio is that if I go ahead and reset the board, we can specify this state as the new norm. So if I go ahead and hit the reset, and we should see, whoops, I need to reselect this and start monitoring, and it's going to relearn, and now it thinks that this is the normal state. Obviously, in your firmware, you can code this to not have this feature, but I find it a very interesting way of updating a model sort of in real time on after it's been deployed. Now, again, I can go ahead and switch this fan off, and it should say that it's identifying anomalous data, sure enough. So we're just under that 90% threshold to identify it as anomalous. Okay, the last step of our demo is to actually see this data show up in NoteHub and generate some alerts. So let's go back here to our sketch really quickly. You can see I've defined a NoteHub project here, and again, I'm going to really gloss over this stuff, but I've got my hub.set request. I've got my note card set into continuous mode, which is going to supply the data to the cloud pretty much instantaneously. Again, I know I'm going with this very quickly, but basically I'm saying every, what is it here? What's my refresh interval? It is every 15 seconds, so every 15,000 milliseconds, I am going to send a note to NoteHub that's called NanoEdge. NanoEdge.qo is the note file name. I'm going to tell it to sync that data immediately. In the body, I'm just going to send that similarity value. So that's all we're doing is sending this data to the cloud. Now let's see what that actually looks like in NoteHub. So I'm going to go ahead and look at my devices. We can see that sure enough, I've got a device that's live online here, so it's communicating data. In our events, we can see, sure enough, I'm seeing a bunch of different similarity data here come through. This is when reporting nominal state here, all the way up to like there's a 48, 10, and so on. So right now, clearly in our, we're sending anomalous data repeatedly. So what I can do is with this data, obviously having it be on NoteHub is one thing, but we want to utilize a feature of NoteHub. It's actually a new feature of NoteHub called the alerts. Now this is available in our development tier and higher, but I can actually specify an alert based on data that's coming from a specific note file. In my case, I've set up a vibration monitor. It's not enabled right now because I didn't want to spam myself with a bunch of notifications, and it's quite a simple UI, but provides some pretty powerful capabilities. All you do is specify the note file that we care about. In our case, I called this one nanoedge.qo, so this is the inbound data from my device. The field that I care about is similarity, right? It's that 0 to 100 value. I want to generate an alert when abnormal data is coming from my device. So I say when my data threshold is less than 90, I'm going to go ahead and generate alert, and it's going to send me a message at my Blues email address. Okay, so let's go ahead and re-enable this and apply the changes. Now, within about 30 seconds, let me log into my email here. Don't mind me taking it off screen for a second just to make sure I'm not exposing any company secrets. I hardly doubt it, but let's see here. All right, coming back, and I'm going to open up this message, and sure enough, I got a vibration monitor alert, and the value is 80. And I'm going to keep getting these because I'm constantly seeing abnormal values coming from my device. Now, a nice other feature of the alerts is that after I've seen a lot of data come through and I'm continually getting these alerts, you probably can't hear it, but I'm getting those Outlook alerts in the background. I can temporarily mute this monitor because I want to keep generating those alerts in my logs here, the logs of the monitor, but I don't want to keep getting the emails. So I know that there's an abnormal event happening on my device, and I just want to go like correct that, but I don't need the notifications over time. So that's it. That was a pretty quick, I felt like I talked at a mile a minute here, but I wanted to give you a kind of a high level demonstration of from 0 to 100 all the way through to generating a model, deploying it to a device, getting that data up on NodeHub, and generating a quick email-based alert, all just using some of the built-in features of NanoEdge AI Studio, the Blues Note Card, and NodeHub. And I'm going to send it back to the other Rob to finish things up here.
All right. Oh, I hate watching myself talk, but anyway, hopefully that demo was helpful in some ways. I just got a couple slides here to wrap up with, and those are available right here. So, oh yeah, if you're a try before you buy kind of person and you're new to Blues, I just wanted to mention that we do have a note card simulator. Actually, it's available at blues.dev. So it's actually a cloud hosted version of the note card firmware, and you can get through our entire quick start process by just using this simulator. Again, available at blues.dev if you want to try it out for free. So to wrap up here, thanks everyone for attending. Thanks again to Jen and to RIoT. Be sure to check out blues.dev for all of our technical resources. You can get your own starter kit as well at shop.blues.com. I've also posted both of those Arduino sketches that I used in the demo in the form of public gists at those two bit.ly short links as well. I'll be sure to send those out in the follow-up email for you if you want to see the details as well. And finally, of course, you can download NanoEdge AI Studio for free from ST at st.com. More likely, you'll do a Google search to find it. ST's site is not super easy to navigate, but that'll give you everything you need to get started and effectively do the same thing that I did in the demo as well. We do have time for some questions. If anybody has any questions, feel free to enter them right now. I don't know if you saw anything that stood out, TJ, while I was jabbering away.
There's a really good one that just came in. The question from Jonathan, is there any way to dynamically update the model based off a certain value after an alert is generated? Basically, like a full, I want to enhance my model, put the new models out, that sort of thing.
Yeah, so you can't change the library, but you can update. So effectively what I did, I mean, basically in your code, you would identify like if an anomalous behavior is identified, base like let me think this through the right way. After an anomalous state is identified, you could trigger a new training session, a new learning session as well, which is what happened in my setup method. So you can absolutely program in all kinds of logic based on different results or different inferences returned from the model. But you can't fundamentally change the library, if that makes sense. Because like I said, it's kind of like a one-way street with ST. You get the model built and deployed, but you can then, within that context on the device, you can do whatever you want.
You can, though. I'm assuming you can do some of the things where if you improve your model just over time with more usage, you could just build an entire new firmware version of it and push it out.
Yeah.
So
Another question, good one that just came in. Since ST, the studio doesn't support Mac, do you have another recommendation for an easy way to get started on a Mac? Two things. I mean, obviously, you could use something like Parallels to get a Windows environment on Mac. That's not ideal for a lot of people, but I don't know. For me, I would tend to use Edge Impulse. That's kind of my go-to platform for machine learning on small devices as well. I think it's a tool that's just as easy to use as NanoEdge AI Studio. They have a very generous free tier as well. I don't work for Edge Impulse or ST, so I feel like I can freely recommend either one of those as an option.
We had a few questions about the video also. So Rob mentioned this at the start, but I'm also just going to drop real quick in the chat a link to our YouTube just for people that have it and want to click it, because we'll be posting the video there a bit after this event too.
Yeah, another good question just came in. Do you know from where ST is pulling its models for selection in a project? Is it updated frequently? That's a great question. I don't know the answer to. I do know that those models are shipped with the download. When you install the project. I don't know how frequently they're updated. If they are at all, I assume they are. I again went through everything so quickly in the demo, but when you show, I believe it's the validation stage, you can see that list really briefly on the right where there's like all those models. The list goes on and on. So there's quite a few, or models, libraries. I conflate those two terms. The list of libraries goes on and on. So you can get a good idea of how many, but I don't know how often they are updated now. Otherwise, if there's no other questions, thanks again, everyone, for attending, and we'll get the recording up for you within the next day or so. And yeah, hit us up on the Blues forum if you have any questions, or you saw my email address, send me an email directly, rlauer@blues.com. That's fine too.
Wire up your anomaly detection, send your anomalies to Rob.
Yep.
He loves getting them.
Yep, send me those alerts.
Thank you, Rob. This was great.
All right, thanks, everyone. Have a great day.
Yep.